Alright, Algebra 2. Welcome to your video lesson. Let's look at lesson 18. We're going to figure out what happens if there is a remainder when we do our polynomial division, right? We are going to use our three different methods. We have synthetic division, we have polynomial long division, and we have our reverse tabular method, right? So, let's get to it. Let's learn what to do with these remainders. Alright, so first of all, the idea is when we divide, right, things don't always go into numbers evenly, right? For instance, 4 is not a factor of 11, right? Because 4 does not divide 11 evenly, right? It goes in there 2 times, and then we have a remainder, right? We have something left over. Same thing is true with this one, right? We'll also say that it's a factor, right? It's a factor if it divides it evenly. So if we were to write 13/4 as a mixed number, how would we write that, right? Well, we could say 4 goes into 13 evenly only 3 times, right? And then what do we have to have left over? We're at 12, right? We have 1 left over, right? So we would call that 3 1/4. We're going to actually be expressing these polynomial remainders in pretty much exactly the same way, except for, of course, they're going to be some polynomial quantity. And just to show you what's going on with this, right? It is true that x plus 2 is a factor of x squared plus 3x plus 2, right? And if we were to factor this, going way back to your Algebra 1 days, right? We'll set this up. Some people call it the double bubble. A lot of people have a lot of different names for what they do. If we're just going to factor it in our minds. The idea is, remember, when I'm factoring, then I need to think of 2 numbers such that when I multiply them, I get 2, but when I add them, I get 3, right? So what 2 numbers do that? Well, 2 and 1, right? And in order for them to add to 3, they both have to be positive. So then we can see that if we were to divide this, right? If we were to divide this, we would just have x plus 1 left, right? Some people might tell you, that they cancel or something like that. But that's what's happening, right? So what we can say is that x plus 2 is a factor of x squared plus 3x plus 2 because it divides it evenly. We don't have any remainder. The answer is x plus 1, right? Just like if I was to say 12 divided by 4 equals what? Equals 3, right? There is no remainder. Same thing here. There was also no remainder here. Let's see what happens if we do have one. So we're going to go ahead and use both long division and the reverse tabular method. Heck, let's throw in synthetic division too, just to get our practice on. So this is the result that we should arrive at. That should be our answer. And let's see. Let's see why that is the case. Here we go. Well, I'm going to go ahead and start with reverse tabular method first. All right, so the first thing I need to figure out is how many rows and how many columns do I need? Well, it looks like I just need 2 rows and 2 columns. Why? The degree of the denominator is 1, so 1 plus 1 means I'll have the 2 rows. The degree of my numerator is 2, so I do 2 minus the degree of my denominator, 1, right? So 2 minus 1, plus 1 is 2. And that's how I got that. And all this stuff goes out here. And I know that I chose my correct rows and columns because each one of those things has a space. And then my divisor will go here. I know that x squared goes there. X times x is x squared. And then I multiply this out. X times 2 is 2x. What did I need to multiply to 2x to get 3x? Why, that was x. And then what do I need to multiply times x to get x? That's 1. 1 times 2 is 2. Okay. Okay, I made a typo. Or a rhino, if you will. That should be fine. Okay. So what's our problem here? These two don't match. Remember, every single time you've been doing your reverse tabular method before, those guys would match. And now they don't. And what that means is that you have a remainder. There is a remainder. How do we figure out what that remainder is from our reverse tabular method? Well, what we do is we say, hey, what do I need to add to 2 to get 5, right? In other words, something plus 2 equals 5. What is that something? It's 3. So what that means is that my remainder is 3. How do we write that result? This is how, all right? So we're going to say, just in the same way that we would write a remainder when we were working with just some sort of integer division, or division with numbers, right? I'll also express my remainder in that same way. So in other words, right, I would write my result, right? My answer is x plus 1, and there it is, right? And where's my remainder? My remainder is right there. Yeah, actually I'm going to make that a little less in the way. So there's my remainder. And then I just keep my divisor in the bottom right here, okay? And you'll see that pattern form as we go through this. All right, let's do some polynomial lone division because it's awesome. Okay, here we go. It's very powerful. Here we go. We are going to divide x squared plus 3x plus 5. All right, so that's got to be an x. When I multiply it out, I get this. I'm going to change the signs and add. And there's our x. Drop down the 5. What do I need to multiply x by to get x? Well, just 1, right? When I multiply that back out, I get 1 times x is x, 1 times 2 is 2. Change my signs and add, and I get, there it is, my remainder. Remember when we were doing it before, at the very end of our problem, we would have a 0. We don't anymore, right? So that means that we have a remainder of 3. And how do we write that? We write it in the same way as we wrote it up above right here. And same thing, just showing you what the remainder looks like, or how we see that there's a remainder when we do each of these different methods of polynomial division. So lastly, let's do this synthetic. And why? Because we can, right? I'm going to do synthetic whenever I can, because it's better. It's quicker. It's more efficient. It's easier once you get the hang of it. All right, so here we go. I've started it out, right? I got my -2 there. That 1 is taking the place of my coefficient of x squared. That 3 is taking the place of my coefficient of x. And the 5 is my constant, or my coefficient of x to the 0 power. I'm going to drop down my 1. -2 times 1 is -2. 3 plus -2 is 1. -2 times 1 is -2. 5 plus 2 is 3. And there it is. That is my remainder, right? So there we go. We have done this division, expressed our remainders, and we understand how we write that in our answer. Let's keep going and have more fun. Fun. Here we go. Let's divide this thing. Long division style, it's going to look like this. Of course, then again, if I was in the real world, yeah, I know, this is real too. But if I was asked to solve this problem, if I was given a test, and something very important depended on my performance, I would use synthetic division immediately. Why? Because in my denominator, my degree of that denominator is 1, and the coefficient of x is 1, which means that I'm all good to go to do synthetic division, but let's get our practice of long division as well. So remember, I need to put a placeholder in here, or placeholders. There we go. In order for this to work properly, right? Okay, what do I need to multiply x cubed by to get, sorry, what do I need to multiply x by to get x cubed? That's going to be x squared. When I multiply that out, I wind up with x cubed minus 2x squared. I'm going to change the sign and add. Drop down my 0x. All right. What do I need to multiply 2x squared by to get, sorry, what do I need to multiply x by to get 2x squared? Well, that's going to be 2x. Multiply that back out. Change the signs and add, and I get a 4x here. And then I drop down my negative 4. And then this must be 4, right? So 4x minus 8. And then I change the sign and add, and I get a remainder of 4. Okay, so how do we express this answer? It looks like this, right? X squared plus 2x plus 4. And then I look at this, okay? What's the sign of this? It's positive, right? If it doesn't say it's negative, it's positive. So that means that I'm going to put a plus sign here, and then I'll write my remainder. My remainder is 4 divided by x minus 2. Okay? And the x minus 2 is just my divider. Reverse tabular method? No, thank you. Synthetic division, please. All right, so I've got my 1x cubed, I've got a 0x squared, a 0x, and a negative 4x to the 0 power. Drop it down. 2 times 1 is 2. 0 plus 2 is 2. 2 times 2 is 4. 0 plus 4 is 4. 2 times 4 is 8. Negative 4 plus 8 is 4. That is my remainder, right? And you remember, that goes right there. Fantastic. Let's keep going. Whew. Reverse tabular method. Maybe I'll do that for a couple. Actually, I'll go ahead and use reverse tabular method for the for 4 and 6. But I would like to use synthetic division on 5. And you know what? If you like to do that using the long division, do it. It's great. It's powerful. It's useful. It's right. It'll get you where you need to be. There we go. And it's also what you'll more commonly see in a college course. You'll more commonly see that long division, polynomial long division, in a college course, at least in my experience. All right, that's going to be x squared. X. Negative 8x goes there. What did I need to add to negative 8x to get positive 4? Well, that's going to be positive 12x, right? Okay, that means that this must be 12. And 12 times negative 8, well, that's going to be the same thing as 80 plus 16, or 96. It's going to be negative, though, right? Okay, well, that's weird, right? And we're still getting used to how to find a remainder with our reverse tabular method. So what I need to think to myself is, hey, what do I need to add to negative 96 to get 10? Okay, so if that doesn't pop into your head right away, just set this up. Hey, x plus, what, negative 96 equals 10, right? You're going to add 96 to both sides, and you wind up with x equals 106. So that means that your remainder is 106. So how would I express this answer? It's going to be x plus 12. All right. This is positive, right? Which means I'm going to put a plus sign there. All right. And then I'm going to put 106 over my divisor. There we go. Let's do some synthetic division real quick. Okay, 1x cubed minus 1x plus 3x, plus 3x minus 1. Let's do this. 1. Negative 3 times 1 is negative 3. Negative 1 plus negative 3 is negative 4. Negative 3 times negative 4 is positive 12. 3 times 12 is going to be 36. Negative 3 times 36. What is it? It's 90 plus 18, or 108. And it's negative. All right. How about I did this correctly? What do you think about that? All right. So I decided in my haste to multiply 3 times 12, when indeed what I should be doing is adding, right? Okay, so negative 3 times 15 is going to be negative 45. So when I add these, I get negative 46. And that's my remainder. Okay, so how am I going to express my answer? My answer is going to be, remember this is, no, we'll write this, our equal sign here. So remember, my degree of my numerator is 3, so this degree has to start off with x squared. It's 1, right? 1x squared minus 4x plus 15. And now check this out. My remainder is negative. So up until this point, we put a plus sign for our remainder, but we're going to use a minus sign this time because our remainder is negative. It's very important that I have the right sign. And there's our answer. Okay, reverse tabular method? Sure, why not? I don't know. Actually, we've done everything but long division. Let's do that instead. Here we go. X squared. Looks like I don't need any placeholders. That's awesome. That's going to be an x. There's an x squared minus x. Change the signs. Add. That gives me a negative x. Drop the negative 19. What do I have to do to get that? I need a negative 1, right? So negative x times negative 1. Sorry, x times negative 1. Negative x. And then I wind up with a positive 1 here. Change the signs. And add. It looks like my remainder is negative 20. So how am I going to express my answer? Just like this. That's going to be equal to x minus 1, right? What I got normally. Minus, remember because I have a minus sign, my remainder is negative. There we go. Well, let's keep going. I'm going to go ahead and use synthetic division on this one. Just because it's my favorite when you can use it. And I think that it's the one that maybe we need the most practice on. Alright. So that's 1x squared minus x, 1x minus 25. Drop that one. Negative 6 times 1 is negative 6. Negative 1 plus negative 6 is negative 7. Negative 6 times negative 7 is positive 42. And when I add these two, I am left with 17. Here we go. So that's my remainder, right? And it's positive. So I'll write that my answer is, well, my degree of my numerator was 2, so I'm going to have to start with x, right? This is a 1x, right? Minus 7. My remainder is positive, so I put a plus sign. And I'll have 17 divided by x plus 6. There we go. Okay, reverse tabular method, here we come. I'll do one of each. Here it goes. Alright, how many rows do I need? 2, right? How many columns? That's 4, minus 1, plus 1. So I need 4 columns. For all of my reverse tabular method fans, you're happy right now, huh? I knew you would be. Alright. X to the 4th. Negative 8x squared. I need a placeholder for my x value. And then I actually missed my placeholder for my x cubed value as well, didn't I? See? All of my reverse tabular method fans are like, hey, you missed that one. Well, here we go. I got a 0x cubed. And then I have a negative 8x squared. And then a 0x. And the 12, all my placeholders are in place. Anyhow, here we go. There's my x and my 2. X plus 2, right? That's my divisor. And let's get this thing rolling. So that's always x to the 4th, so this has got to be x to the 3rd. X to the 3rd times 2 is 2x to the 3rd. What do I need to add to 2x to the 3rd to get 0x to the 3rd, but negative 2x to the 3rd? What do I need to multiply times x to get negative 2x to the 3rd power? That's going to be negative 2x squared. Then we're going to multiply that out. That'll be negative 4x squared. What do I need to add to negative 4x squared to get negative 8x squared? That's negative 4x squared. Then up here, it's got to be negative 4x, right? Down here, I'll multiply. Negative 4x times 2 is negative 8x. And what do I need to multiply the negative 8x to get 0x? But 8x. 8x times, or sorry, x times 8 gives me the 8x, right? And then this is 16. So now I need to ask myself, hey, what do I need to add to 16 to get 12, right? In other words, x plus 16 equals 12. What is that? That is negative 4. Negative 4. So my remainder is negative 4. So then my answer to this thing is x cubed minus 2x squared minus 4x plus 8. My remainder right here, this is my remainder, right? This is it. It's negative 4. My remainder is negative. So I have to put a minus sign there, and I'm going to put this over my divisor. There we go. Little reverse tabular method for you. Hey, let's do some long division here. Hopefully I just gave myself enough room. We'll see. 4x cubed. I need an x squared placeholder. I've got my 5x, and then I've got my negative 8. What do I need to multiply 2x by to get 4x cubed? 2x squared. So that's 4x cubed minus 10x squared. Change the sign and add. That's 10x squared. Drop down that positive 5x. What do I need to multiply 2x by to get 10x squared? That is going to be 5x, right? When I distribute that 5x, I get 5x times 2x is 10x squared, and 5x times negative 5 is negative 25x. I'll go ahead and change the sign, sorry about the messiness, and add. This becomes 30x. Drop down that negative 8. What do I need to multiply 2x by to get 30x? That's going to be 15x, positive, right? Not 15x, but just 15. When I multiply that back out, I have 30x minus, and that's going to be 30. Sorry about that. 5 times 15. Anybody? Bueller? Oh, wait, there's no one in here. I guess I'll do it instead. Hey, isn't that the same thing as 50 plus 25 or 75? Okay. I'm going to change the sign and add, right? So that is going to give me positive, right? You're going to have a positive 75 there. That's going to be positive 60. There we go. That's my remainder. So how do we express this answer? I'm a little out of room there, so I'm going to write it down here. Oh, we'll keep it right there. That is going to be 2x cubed plus 5x minus 8. My remainder is positive, so I put a plus sign. And I put that remainder over my divisor or my denominator, if you will. Boom. Done. And we'll work on this exit ticket when we come in tomorrow. It'll be fun. I promise. Hey, you know what? You guys are awesome. I hope you were able to watch this comfortably. And I know I'm really fast, but we've done this division before. You guys have been doing awesome. I appreciate you, and I hope that you have a fantastic evening. Goodbye.